Hi everyone, I am here to explain the Routh stability criteria of a system. Here in Routh stability criteria, we are going to discuss the stability of the system, and in for the system to be stable, it is necessary and sufficient that the each element of the first column must be positive for a not greater than 0. That is, that first element of each each element of the first column is positive for a naught, that is the first element greater than 0. If this condition satisfies the Routh if this condition satisfies in the Routh array, then the system is stable. And if an element in the first column is negative, then the sign changes. The number of sign changes. That is, if h2 is negative, the sign change will be from positive to negative and negative to positive. There will be two sign change. The number of sign changes will be equal to the number of pole in the right half of the S plane. That is, if there is an S plane and if the number of sign changes 2, then there will be two pole in the right half of the S plane. This is the right half of the S plane to make the system unstable. Okay, then I'm going to discuss the Routh array. In Routh array, yeah, first we need to write this Sn minus 1, Sn minus 2 from the standard equation a naught into s raised to n plus a1 into s raised to n minus 1 plus a2 into s raised to n minus 2 dot 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 plus a n minus 1 into s plus a n into s raised to 0, that is 1, is equal to 0 till first write sn minus 1, sn minus 2, sn minus 3 dot 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 s raised to 1 into s raised to 0, sorry, uh, last s raised to 0. And here we are using these first two rows to write the elements of the p of s, that is the first two rows only. How to write? You first write a0, then a1 just down next row, then a2 the previous row, a3, a4, a5, a6, a7, a8, a9, a10, a11, a12, a13. Likewise it continues till an, and we will find all other element using a standard symbol formula. I will explain it, but uh, however, if we calculate the and come to an end, the final value will always be an, that is the last element in the standardized equation, that is constant. It will be always an. Do remember, it's an important point. Okay, we can find how now see how to find the values of s1, s2, y1, y2, etc. For finding s1, we need to take a0, a1, a2, a3, a0, a1, a2, a3. Here a0 into a3 minus a1 into a2 divided by a1 is x1. Likewise, for y1 we need to take a0, a1 and a4 and a5. Therefore, a0 into a5 minus a4 into a1 into a4 divided by a1 is equal to y1. Likewise, z1 we need to take a0, a1 and a6, a7. So a0 into a7 minus a1 into a6 divided by a1 is equal to z1. For Z2, taking Z1 as the reference, the remaining term will be changed. Likewise, like is H1 into A3 minus A1 into Y1 divided by H1. The H1 into A5 minus A1 A3 A1 into Y1 A1 into Z1 divided by H1. H1 into A7 minus A1 into W1 divided by x1. These are the terms for h2, y2, z2 and w2, etc. Okay, let us discuss the problems in stability criteria problem. There are four varieties of problems. The first step one is stable, second one unstable, third one each element in the row is zero if any of the first in any of the row the first element is zero, that is first element of any row is zero. It's another condition. These 3 and 4 are special condition, and 1 and 2 are the stability conditions, standard stability conditions. In this stability conditions, if P of s given s raised to 4 into 8 s cube plus 18s plus 16s plus 5 is equal to 0. This is an standard normal question. Here, look, s the maximum power of s is n. Here, n is equal to 4. Therefore, first we are going to write this power of s to the power 4, s to the power 3, s square, s raised to 1, s raised to 0. Then we will write fill the first two rows with the values of coefficient of s raised to n. 1, 8, then 18, 16, 5, 0. We will write an extra column here. We will put to all zeros to easily write all the other values. 1 into 16 minus 8 into 8 divided by 8 is equal to 16. That we wrote here x1. And 1 into 8 into 5 minus 1 into 0 divided by 8, that is 5. We are wrote here. Then 8 into 0 minus 1 into 0 divided by 8 is equal to 0. We have written here. Likewise, we are solving the all other element. Look, 13.5 is 16 into 16 minus 8 into 14 divided by 16 is 13.5. And look how we will get that 5. 13.5 into 5 minus 16 into 0 divided by 13.5. Is 16 into 0 here will be 0, and 13.5 divided by into 5 divided by 13.5. 13.5 will be cancelled and 5 will be remaining. Then automatically that an will be the last term for s0 the value. Okay, that will not change any time for any problem. Okay, we will check the stability. Here a naught is equal to 1, which is greater than 0. And also the first element, all the element in the first column is positive, therefore the system is stable. The type 2 problem, that is if unstable problem. Here look, 3 into s raised to 4 plus 10 s cube plus 5 s square plus 5 s plus 2. Here the normal method only, writing firstly writing the s raised to 4, s raised to 3, s square, s raised to 1, s raised to 0. And here n is equal to 4, filling the first column, first two rows, and finding all the elements using the standard forms. We will get one value has negative. So for a naught is equal to 3 greater than 0, one element in the first column is negative. Therefore, the system is unstable. Since unstable, we need to find the number of poles in the right half of the S-plane. We need to find the number of poles in the right half of the S-plane, in the right half of the S-plane, to make the system unstable. Here, number of poles is equal to number of sign changes. There are two sign changes from s square positive, s raised to minus, s raised to 1 negative, s raised to 0 positive. There are therefore two sign change from positive to negative and negative to positive. Therefore, n is equal to 2 and number of poles is equal to 2. There are two poles in the right half of the S-plane for to make the system unstable. Okay. Then the next type is the uh, all the element in the row is zero. It's a problem. We cannot continue with that type of problem. So we need to modify that position. Okay, there we need to remember that if there is if all the element of the row becomes zero, we need to stop at that point, and we should remember we need to modify that way. We modify that row. I how to modify I will explain. The row above the row, that is 2 6 minus 8, we should take that row and check. Here the s power of s is 4, then we should take s to the power 4 h square s into power 2 s into power 0, that is even number reduction. We should write uh, with the even number reduction. Then we will get our auxiliary equation as a of s is equal to 2 into s raised to 4 and 6 into s square minus 8 into s raised to 0 is equal to 0. Differentiate this auxiliary equation with respect to s, we will get 8s cube plus 12s is equal to 0. And now we have got the modified row by this coefficient of s cube and s, 12 and 8 and 12, and other element is 0. Then writing the same Routh array by modifying that s cube array with 8 and 12, we will continue with the further steps, and the last element will be minus 8 only. But check, the here the last element is minus 8, so therefore for a naught is equal to 1 greater than 0, there is one element in the first column to make the system unstable. Therefore the number of poles in the right half of the S plane is equal to 1 for the to make the system unstable. Even though we not directly say from the question itself that minus 8, since the system is unstable, but we are doing this to find the number of poles in the right half of the plane. If we don't know that if there is any negative values in before that before the route before the another rows, so in any of the first any element in the first column in negatives, therefore the number of poles in the right half of the plane will increase. That's why we are done the Routh array to discuss to find the number of poles to make the right half of the plane to make the system unstable. Okay, and the last type, it will not be it's a little bit confusing, not too difficult. Let's check. If P of s is equal to s raised to 4 into s plus s cube plus 2s square plus 2s plus 5 is equal to 0, if one of the element in the if first element in any of the row is 0, it's a problem. We cannot continue with that step. Okay, there are two ways to solve this. I prefer only the first step and put s, replace s by 1 by z in the previous equation. Okay, and we will get p of 1 by z is 1 by z raised to 4 plus 1 by z cube plus 1 by z 2 by z square plus 2 by z plus 5 is equal to 0, and multiply the highest power of z, that is power of s into, that is here n is equal to 4, that here z raised to n is equal to z raised to 4, that then multiplying the whole equation into z raised to 4, we will get one equation with no denominator. So because it's not easy to solve this problem with 1 by denominator as a variable. That's why we are multiplying it, and we will get an auxiliary equation like this. But we if we write from right to left, we will get the standard auxiliary equation similar to the Routh equation. We will form the Routh array right now. We will not get 0, instead we will get some values. Here its value is negative, therefore For a naught is equal to 5 greater than 0, the element in the first column is negative, is one element in the first column is negative, therefore system is unstable, and the number of changes is equal to 2 is equal to the number of poles shifted to the right half of the plane is 2. Okay, and the second type of problem is replace the element 0 by sigma, and the next element we need to find by using standard form 2z minus 5 by sigma, and we will limit the sigma to 0. Okay, there will be a limit to solve the problem. Okay, in the limit I have solved here separately. 2 minus 5 by sigma, that is, you are splitting this value and cancelling this sigma here, you will get 2 minus 5 by sigma, and put that sigma tends to 0 to 0 here, you will get 5 by 0 as infinitive. So okay, to minus infinitive, that is minus infinity with respect to any value is minus infinity only. Putting that minus infinity, there is a sign change, and the system is unstable for because for a1 a naught is equal to 1 greater than 0, the first element, the one element in the first column is negative, therefore unstable, and there's two positive sign change, uh, 2 sign change from in s square s raised to 1 s raised to 0, therefore two number of poles in the right half of the plane to make the system unstable. Okay, you check here we are directly written 5, it's even though if it is infinity, so that's why I said earlier we can, you should directly write 5 here. In this condition you should not check that infinity, even though infinity by infinity is undefined, you should directly write that 5 value here. Okay, the, from that we have concluded the all the all type of problems in router array. Thank you.